Okay, welcome to another episode of Fun Times and Statistics. We are going to be looking at reviewing for our first exam today, and we're going to start by covering problem number 8 in our review. So this is a little bit of a difficult problem for a couple different reasons. So you've got this information that the police estimate that 80% of drivers wear their seatbelt, and they do a safety roadblock and stop and check cars for seatbelt use, and they stop 120 cars, and they want to know what's the probability they find at least 20 drivers not wearing their seatbelt. So I'm going to pull up the notebook so we can get started with this problem. So when I look at that probability statement, I don't know what this is. It's fine, don't worry about it. I'll just erase that. I ask myself, hey, what does this really ask me? Well, you want to know the probability that when you do this, the number of drivers you get is greater than 20, right? Or the proportion of drivers you find that is, out of the 120 is greater than 20. Now, here's where you got to be careful. You got to be careful how you define your proportion. So you could think about this two ways. You could think of not wearing your safety belt as a success and wearing your safety belt as a failure, and then this would be what you want. Now, alternatively, what you could do is think about it as, oh, well, I want, wearing my seatbelt to be a success, in which case, I want the number of drivers that are wearing their safety belt to be, oh, hold on, out of 120. So we're going to do the opposite game. Ready? So if I want, at least 20 not wearing their belt, that means at most 80 are wearing their belts. So at most 80. That would be the opposite one. So here this would be your success is wearing the belt. And here your success would be not wearing it. I accidentally hit the eraser, sorry about that. And this is the one I'm going to go with for now, just because I've already got that one set up, and that's the way I sort of did it in the review. So this is the probability I want to find, and since this is clearly a proportion, I need to do the normal approximation to the binomial to come up with the appropriate mean and standard deviation and figure out what's going on here as far as coming up with the normal approximation. So what I want to do is I want to do the normal approximation to the binomial. So I need to know my mean and my standard deviation so I can calculate my probability, and hopefully remember the mean for this is just n times p. So for us, that would be 120 times, now be careful, my success is not wearing the belt, and so since the police found the population proportion of those who do wear belts is 80, the success of not wearing a belt is 0.2. So if you calculate that, that's 24 people. And then the standard deviation is the square root of n times p times q. So that would be 120 times 0.8 times 0.2. And I calculated that ahead of time to be, did I calculate that ahead of time? Oh, I did. It's a 0. Sorry, I had to look it up. 0.365. So next I need to take that probability statement I have up above. I'm going to rewrite it down here. The probability that my proportion is actually, oh, I didn't need a hat there. Because it's about a sample and I'm not doing that. Is greater than 20 out of 120. So if I transfer that into a z, I'm looking at the probability that the proportion I'm interested in minus my mean, 24, divided by my standard deviation, 0.0365, which is equal to, 20 divided by 120 minus, oh, that's not my success. Sorry about that. This has gotten really confusing. Because this should be my mean of proportions. I have gotten this wrong. Because I want to find, oh my god, I don't need a z for this. Because I have my mean and standard deviation. My mean is just p, not np. Why am I doing this wrong? I don't know. I'm not going to fix this video. I don't have time. Oy, oy, oy. So my z, because your teacher did it wrong, is 20, because it's p. The z-score for this is p hat minus your hypothesized p divided by your standard deviation of p. So I was using my number of successes, which is not the right value for my mean, because it's 0.2. It's not that. Okay, sorry about that. 0.0365. Let's move it down a little, get some more space, and calculate that. I am going to pause this. Sorry, my screen started to move on me, and now I'm having problems, technically. Okay, so if you calculate that fraction, you get that z is greater than negative 0.913 and some change, which you could look this up on the normal distribution. And if you wanted to do normal tables for this, you'd actually have to do 1 minus the probability that z is less than, because it always does area to the left, minus 0.91, again, because it always does area to the left, and you only get 2 decimal places, so you'd have to do 0.91. So that's how you do it using tables. Which I'm not going to use tables for this. I'm actually going to use Minitab. So for me, I used Minitab to do graph, normal, or sorry, not that, probability distribution plot. And I chose normal. I used my mean of 0.2, my standard deviation of 0.366, and I plugged in this z-score value that I wanted. Or sorry, not this z-score, but the 120, the 20 over 120, which is approximately 0.16 repeating. So, that's what I used. And I got that the probability is actually 0.819, a little bit more than that, but that's what I'm going to round it to so that it matches the z-table. Alrighty, so that so far ends number 8. Next up, we have number 13. I'm going to check how long this recording has been going. Yeah, that's too long. We're going to have to stop it here. Stay tuned for number 13.